Now we're going to continue talking about the sum and difference identities for sine. Please notice that when we're doing the sum of two angles, we're going to be adding the products that we're using. When we're doing the difference, we're going to be subtracting. Now this is a little bit different. We're going to take the sine of the first angle and multiply it by the cosine of the second angle. We're going to add that. To this time, we switch out the function. This is now going to be cosine of the first angle, sine of the second angle. If you get this part, and then just remember to switch the order of the functions, you're going to get that. Again, since I'm doing the difference, and this is a sine problem, it's going to be the difference of the products. Sine of the first, cosine of the second, cosine of the first, sine of the second. So I'm going to do the sine of 75 degrees, and I'm thinking of 75 as 45 plus 30. So 45 would be my U angle, 30 would be my V or second angle. So it's the sine of 45 times the cosine of the second angle. Since it's a sum, we're adding in this case only. So it's the cosine of the first angle, sine of the second. Square root of 2 over 2, square root of 3 over 2, which is the square root of 6 over 4. I made a mistake, so I wrote back over that with 4 blue so you can see that. Cosine of 45, square root of 2 over 2, sine of 30 is 1/2. Square root of 2 over 4. I'm simply going to add my numerators together and get square root of 6 plus the square root of 2 over 4. Now I want to point out something. We've seen that value before, because the cosine of 15 degrees was exactly the same number. And that should be the case because 75 and 15 are complements of each other. So the cosine of 15 should be exactly the sine of 75. So that's affirmation that we're doing this right. Okay, now in example 5, please notice we're trying to find the sine of a negative 15 degrees. So I'm still using that 30 and that 45 degrees, but I'm using them in a way to subtract to get a negative value. So I'm doing the sine of 30 minus 45 degrees. Since this is a difference, I'm going to be using subtraction over here in my answer. It's going to be the sine of the first angle, cosine of the second, and then switch that up. Cosine of the first, sine of the second. That's 1/2 times the square root of 2, which simplifies into the square root of 2 over 4. Cosine of 30, square root of 3 over 2, square root of 2 over 2, the square root of 6 over 4. There's that minus sign. And so that simplifies into the square root of 2 minus the square root of 6 over 4. And while all of our answers are looking very familiar or similar, we haven't got that answer exactly up until this point. Now, the next one we want to do is a difference problem for pi over 12. Now, when we were doing cosine, we did it for a sum. We were able to add two values and get 5 pi over 12. But let me talk about how to do a difference. In a difference, I need to subtract two values that are going to have a 1 pi over 12. Now, this is the secret. We're going to be looking for values that will subtract to give us 12, but those numerators need to be multiples of 12. So those numerators should be multiples of 12. And so what I was thinking about was maybe if we did pi over 4 pi over 12 minus 3 pi over 12. That would give us what? Pi over 12. And pi over 12 reduces to what, y'all? Reduces to 3 pi over, it reduces to pi over 3, and 3 over 12 reduces to pi over 4. So this is the way I was thinking about it. Pi over 12, I need two values that would subtract to give me a 1. So 4 take away 1 would give me, 4 take away 3 would give me that 1. But I need the 4 and the 3 to be multiples of 12 that would reduce. And so they do reduce down, just like I was trying to explain to you, where pi over 3 would be my u value, pi over 4 would be my v value. I am trying to do a difference, so it's the sine of the first, cosine of the second, minus cosine of the first, sine of the second. And we've been working with these values all day. So this is the square root of 3 over 2, square root of 2. Go ahead and multiply that out. That's the square root of 6 over 4. That's a minus sign there, y'all. Cosine of pi over 3 is 1/2. Sine of pi over 4 is square root of 2 over 2. That multiplies out to be square root of 2 over 4. So that's the square root of 6 minus the square root of 2 over 4, I believe.